The other portion of 4.5 day 1 is going to revolve around solving equations. For this first example of out of 2, we're going to solve cosecant and secant equations based on some methods that we've learned in the last unit. So here are the steps that I'm suggesting when we have familiar ratios. This is going to be when we're talking about the special angles, the familiar ratios. If it's not that way, then refer to the next video that doesn't have these familiar ratios. So step 1 is just going to be convert to a more familiar ratio. So what I mean by that is here we have cosecant. I don't like cosecant because it just, you don't really work with it as much as the one that goes with it. And so what I'm going to do is I'm going to convert that to sine. Now I can't just willy-nilly convert that to sine. That is the reciprocal of cosecant. So if I want to do that to one side, I have to do the reciprocal on the other side, and that makes 1/2 for this side. Okay, so that's my conversion to a more familiar ratio. That looks a lot better to me right now than what it was initially. Second thing is to use a reference triangle to find out the missing angle. Now, in order to use a reference triangle, as we talked about last unit, we should figure out what quadrant we're dealing with. So it says here, you'll notice it says x is between pi over 2 and pi. Now what that means is we're talking about pi over 2 being right here and pi being right here. They're the angles on the unit circle. So that means we're talking about quadrant 2, and we're going to draw this triangle in quadrant 2 to solve this. So now that we have that, we want to make this triangle, we want to orient it in some way here so that the sine, the opposite over the hypotenuse, is equal to 1/2. Well, that's a 30-60-90 ratio, and so I want it so that the opposite over the hypotenuse is 1/2. I'm going to draw it this way. Make it like that. I'm going to make it the 1/2, and the 1 right there, that's going to make this negative square root of 3 over 2. Negative because it's in the second quadrant, but it's not going to do much to us in this example. Now, the 1/2, that's the one that's across from the 30-degree angle. So this is a 30-60-90. It's 30 degrees above the x-axis, which puts it at 150 degrees as far as we know, because it's 180 minus 30. That makes it 150. Now, that's great and everything, but notice that this initial range, or this domain that we have here, is saying pi over 2 and pi. So this problem is assuming radians. That means that we just have to output our final answer in terms of radians. So if you go into your unit circle, take a look at, if you're not familiar with this yet, use your unit circle, but 150 degrees is the same thing as 5 pi over 6. If you wanted to just straight up convert it, just multiply by pi over 180 and simplify, you could do that too. But we're most interested in the radian version of this angle, and so now we've solved that. That's our missing angle given that initial problem.